This next lesson is a short one, and it's even a little bit shorter because I covered some of this earlier. So this is on numeric data types that are built into Scala. Here you see Scala's 6 numeric data types, and also when you're using really large numbers, you can use BigInt and BigDecimal as well. And I can demonstrate these in the Scala rep. The easiest ones to demonstrate are int and double because those are assigned by default by Scala, by the Scala compiler. So what I mean by that is if you type val a equals 1, 1 defaults to being an int or an integer value. And if you wanted a different type, for instance, if you wanted a short, then you would say a colon short equals 1, and that reduces it to a short. If you wanted it to be a, let's say a long, I would make it like that. And I forgot about byte, so byte is even smaller. So if I wanted it to be a byte, it would be that. I'll show what these data types mean in just a few moments, but for now, when you're dealing with numbers that don't have floating point values, these are the 4 types. And again, it defaults to int, and if you want short, long, or byte, you have to declare that when you create the variable. And another way to create a long is to say, we could do a equals 100L, for instance. So the L at the end of that makes that value a long. And similarly, when you do get into floating point numbers, we can say val a equals 1.2345, and that will default to a double. And if you wanted that to be a float, you can either put an F at the end of that, or you can say colon float like that. These data types, or the names of these data types, only make sense if you know what they stand for. So in the book, Learn Scala 3 the Fast Way, I include a table that shows all these data type sizes. Unfortunately, it splits across 2 pages, but on this first one, you can see that a byte is an 8-bit signed 2's complement integer, and what that means is that the data range goes from -128 to +127. And again, that's a byte. So if I go back here and I say val b for byte equals, oops, excuse me, I do have to include the type, so that makes it a byte. And then if I try to go beyond 127, so let's go to 128, kaboom, we get an error here. So the compiler is like, oh, okay, you required this to be a byte, but you're giving me a value that's too large. And then if you go back to the book, you can see the data ranges for these other types. So the data range for short is shown here. Data range for int is shown there. And then long, float, double, and even char is a 16-byte unsigned, and it goes from 0 to 65,535. And now when you need larger values, which is really common in big data applications, you can use BigInt and BigDecimal. So earlier I had val I, something like val I equals 1, and that of course is an int or integer. And now we can say val I equals BigInt. And there are several different ways to construct these. I believe you can pass in strings. So we could say 1, and another way is to pass in numbers. So you could make that a BigInt 1, 2, 3. You could also make it a BigInt, and I think this is where the string part comes in, is you can just kind of keep going. Oops, like that, to create a BigInt and then a BigDecimal. So a BigInt is analogous to an int in that it is intended for integers. And then a BigDecimal, we could say val a equals BigDecimal. And you can create it like 1_234.567. That's a BigDecimal. I could have, keep going there. .89 there, kapoom, like that. Then if you want to learn more about these classes, you can look them up in the Scala doc, the official Scala doc. So here I'm looking at the BigDecimal class, or the BigDecimal type, right there, and it gives you a bunch of documentation here that shows what a BigDecimal is, and that talks about precision approximately matches that of IEEE 128-bit floating point numbers, and so on and so forth. So you can read all that there. And a really nice thing about BigDecimal, if we scroll down here, is that it has many methods. So just like you work with division, subtraction, multiplication, and addition with the other data types, you can also do that with big decimal types. So I'll keep the type small, but I would say val A equals big decimal, make that 1, and then we could say val B equals a big decimal of 2, and then we could say val C equals A plus B. So it has these typical operators that you have that you're used to, I should say, with int and double and float and long and so on. And also, when we come back to the big decimal Scala duck, you'll see that it has methods to convert a big decimal to other numeric types. And very importantly, it also has methods to test whether the big decimal can successfully be converted to these types. Also, when it comes to the size or the data ranges of these built-in data types, I include these in my book, Learn Scala 3 the Fast Way. I also have them on my website, and I believe they're on the official Scala language website as well. But one other way you can see them is you can come into the REPL and you could say, type in. So what you do is you type in the name of the type that you're interested in, and then you can say max value, and that shows you the max value, and then you can do the min value, and so on. So these types that you can see in the REPL should match what I have in the book. And then like an easy one to do is short dot min value and short dot max value. And then you'll see that those match what I have here in the book. And finally, one thing I showed but I forgot to discuss is that when you create variables, when you create values, you can use this underscore syntax. So it makes numbers easier to read. So, if you look at a number like that, you're like, well, I think that's either 10,000 or 100,000. I can't really tell. But a nice thing is you can put underscores on these now so you can tell that's that value, and that makes them much more readable. And then you can also do the same thing with floating point numbers. So you could say 1 underscore 234, 1 underscore 234 underscore 567 dot 89, and an equal sign would be very helpful right there. There we go. So in both of those situations, you can use underscores to make numeric values easier to read. As a quick recap, I showed these 8 numeric data types going from byte to big decimal. Then I showed examples of how to create all the numeric types. And finally, I showed their data ranges.